What if some of the most important oceans in the universe were hidden in complete darkness? Not under clouds, not beyond a distant horizon, but buried beneath miles of ice, locked inside frozen worlds, far from the warmth of the sun. Because tonight, we are stepping gently into one of the strangest possibilities in all of space science. That some of the most promising places for liquid water in the solar system may not be on planets at all, but deep beneath the icy shells of distant moons. Silent oceans, hidden oceans, worlds with seas no human eye has ever seen. So let the room grow quiet, let the day move a little farther away, and stay with this for a moment. If an ocean could exist in total darkness, sealed beneath ice, what might be living in that silence? And what would it mean if the universe had been hiding whole seas in places we once assumed were dead? Now, let's begin. At first, the idea sounds wrong. When we think of oceans, we think of light, open water, waves, sky above, a horizon, color, movement, the living brightness of the earth. We are used to connecting water with sunlight, and sunlight with life. That feels natural, almost automatic. But the solar system has been quietly teaching us something deeper. An ocean does not need an open sky. It does not need blue light. It does not even need to be visible. It may only need the right pressure, the right chemistry, the right source of internal heat, and enough time. That is what makes these hidden ocean worlds so haunting. They ask us to imagine seas without weather, tides without beaches, water without daylight, depth without reflection. Imagine this: a moon covered in ice, its surface hard, pale, silent, and ancient. From the outside, it looks frozen all the way through, the kind of world you would dismiss in a single glance. Cold, dead, sealed shut. And yet, far below that ice, there may be a global ocean. Dark, salty, under pressure, moving slowly through a buried world no sunlight has touched for ages beyond human history. That is one of the most beautiful shocks in modern planetary science. A frozen surface can hide a living possibility. The first great name in this story is Europa, a moon of Jupiter. Bright, cracked, icy, beautiful in a way that almost feels clean. From far away, Europa looks like a frozen shell marked with long, dark lines, a smooth, white world crossed by scars. But those scars may be telling us something extraordinary, because Europa is not just ice, or at least not only ice. Beneath that shell, there is strong evidence for a deep, liquid ocean, perhaps a global one, perhaps containing more water than all the oceans of Earth combined. Pause there for a moment, because that idea should feel enormous. A world smaller than our moon, holding a buried sea greater than Earth's, and not under open sky, under ice, under pressure, under darkness. Imagine this. You stand somehow on Europa's surface. Above you, the sky is black. Jupiter hangs vast in the distance, filling space like a god of storm and gravity. Beneath your feet, the crust is frozen and hard, silent. But miles below, an ocean may be shifting through the dark, a hidden sea beneath a frozen shell, a place no sunlight reaches, and yet not empty, not necessarily dead, not necessarily still. This is where the imagination begins to change shape. Because Europa is not interesting only because it is cold. It is interesting because it may be active. Its ice shell may flex under Jupiter's gravitational pull. That flexing creates heat. Not surface heat, internal heat. Enough perhaps to help keep an ocean liquid below. That is one of the recurring themes of hidden ocean worlds. They are not warmed mainly by sunlight. They are warmed from within, by tidal forces, by internal energy, by the quiet violence of gravity. And this is important, because once internal heat enters the story, a frozen moon stops being simple. Cold outside does not mean frozen all the way down. Imagine this, a world locked in darkness, and yet deep inside it, pressure and friction and chemistry continue. The surface may look still, but the interior may be working, quietly, relentlessly, creating the conditions for liquid water beneath a shell of ice. Europa is not alone in this. Another moon, even stranger in some ways, waits farther out, Enceladus, a small moon of Saturn, much smaller than Europa, bright, icy. At first glance, too small to seem so scientifically powerful. And yet, Enceladus gave us one of the most stunning discoveries in the outer solar system. Water was not just suspected there. It was seen erupting into space. From fractures near its south pole, Enceladus sends plumes of water vapor, ice grains, and other materials outward into the dark. Great cold geysers, jets from a hidden interior, a buried ocean announcing itself through cracks in the ice. That changed everything, because it meant we were no longer talking only about inference, not only about indirect hints. Enceladus was actively releasing material from inside itself, a hidden ocean world speaking into space. Imagine this, a tiny frozen moon drifting in silence near Saturn, its surface pale and cold, its scale deceptively modest. And then, from its southern fractures, plumes rise into the black, water from beneath the ice, a secret sea venting its breath into space. There is something almost unbelievable in that image, that one of the clearest signs of liquid water beyond Earth might come from a moon so small, so cold, and so outwardly quiet. And it gets even stranger. Those plumes contain more than water alone. They have carried salts, organic compounds, signs of internal chemistry, evidence that the ocean below may be interacting with rock at the seafloor. That matters because on Earth, where water meets rock under the sea, chemistry becomes powerful. And where chemistry becomes powerful, life becomes a possibility worth taking seriously. Not proof, but possibility. Real possibility. Imagine this, an ocean buried under ice, no sunlight, no blue sky, no waves breaking in the open air. And yet below, perhaps, warm mineral interactions, chemical gradients, energy sources, the kind of conditions that make astrobiologists pause and look again. That is why hidden ocean worlds are not just visually beautiful ideas. They are among the most serious places to ask one of science's oldest questions. Could life exist elsewhere? Not necessarily intelligent life, not forests, not fish, not civilizations under the ice. The universe does not owe us anything so dramatic, but microbial life, simple life, persistent life, the kind of life that might survive in darkness if the chemistry is right. That possibility changes everything, because it means habitable worlds may not need to look habitable from the outside. A frozen shell can hide a living chance. A silent moon can hide a moving sea. A dead-looking surface can conceal one of the best places to search for life beyond Earth. Imagine this. Human beings once looked outward and assumed that warmth and light on the surface would define the best places to search. Planets near stars, open atmospheres, visible landscapes. But now the map has widened. Now some of the most compelling worlds are cold above and wet below. This is one of the great quiet revolutions in modern planetary science. Life, if it exists elsewhere, may not be waiting under sunlight. It may be waiting beneath ice. And hidden oceans are not only a story about water, they are a story about humility. Because they remind us that the most important environments are not always visible ones, that what matters most may lie under the surface, that stillness can hide motion, that silence can hide depth. Imagine this, an entire ocean sealed beneath a crust so thick and cold that from far away the world seems simple, frozen, final, unchanging. And yet beneath that simplicity, a sea, dark and pressurized, holding movement, holding chemistry, holding possibility. That is what makes these worlds so haunting. They force us to separate surface appearance from inner reality, and that is a pattern the universe seems to love. Europa, Enceladus, and soon, in the next part, Titan as well. Different worlds, different chemistries, different structures, but all of them teaching the same lesson. The solar system may be far wetter, stranger, and more secretive than we once imagined. For now, rest with this. Some of the most fascinating oceans in the solar system may not lie under open sky. They may lie in darkness, beneath ice, inside worlds that looked dead until gravity, chemistry, and careful observation taught us to look again. Now we go deeper. Because once you accept that frozen worlds can hide oceans, another question begins to rise. What are those oceans actually like? Not in poetry, not in metaphor, but as real places, real water, real pressure, real darkness, real chemistry. And this is where the mystery becomes even stronger. Because these are not simply buried seas, they may be entire environments, whole worlds of water hidden under ice, worlds with depth, movement, layers, currents, and perhaps, under the right conditions, the raw ingredients of life. Imagine this. You are no longer thinking of Europa as a bright frozen moon in the distance. You are thinking of it as a shell, a cold outer lid over something vast below. The ice above may be many kilometers thick, fractured, shifted, scarred by stress. And under that frozen ceiling, a global ocean may extend across the moon, dark and silent, pressurized and immense. That should feel almost impossible. A whole sea beneath a crust of ice, on a world so far from the sun. But distance from sunlight is not the whole story, because sunlight is not the only source of energy in a world. Gravity can also heat. Europa is constantly pulled by Jupiter, not in a simple way, not as a single clean tug, but through an ongoing tidal struggle. Its orbit is slightly stretched, its shape is flexed, its interior is squeezed and released, again and again. And all that flexing generates heat, not enough to make the surface warm, but perhaps enough to keep a deep ocean from freezing solid below. That is one of the strangest lessons of ocean worlds. Cold surfaces can hide warm interiors. Stillness can hide motion. Distance can hide energy. Imagine this. Europa from above looks quiet, a pale sphere streaked with dark lines, a frozen body drifting around Jupiter. But inside, gravity may be doing continuous work. The moon flexes, heat builds, ice shifts, water remains liquid in the depths. The whole world is more active than its silence suggests. This matters because hidden oceans are not just interesting for their water. They are interesting because water plus energy becomes a much more serious possibility. Water alone is not enough for life. But without liquid water, life as we know it becomes much harder to imagine. And once liquid water is joined by internal energy and chemistry, the question becomes much more alive. Now imagine the seafloor beneath Europa's hidden ocean, far below the ice, far below the dark water. Rock, minerals, pressure, perhaps even hydrothermal activity. That idea matters enormously, because on Earth, some of the most astonishing ecosystems live far from sunlight. Down near hydrothermal vents on the ocean floor, life survives and thrives using chemistry rather than daylight. No sunlit surface is required. Only liquid water, energy, and the right chemical conditions. That does not prove Europa holds life, but it changes the logic of the question. It means a dark buried ocean is not automatically dead. Imagine this: a world with no sunrise over its sea, no blue surface, no open horizon, and yet down below, chemistry flows. Minerals interact with water, heat seeps from rock, energy gradients form. The environment may be severe, alien, and difficult beyond anything on Earth, but it is no longer easy to call it empty. That is why Europa keeps returning in scientific imagination. Not because we know life is there, but because it may be one of the best places in the solar system where life could exist outside Earth. And then there is Enceladus. Smaller, brighter, more outwardly fragile, but in some ways even more startling. Because Enceladus does not only hint at an ocean, it sprays evidence of that ocean into space. Imagine this: a frozen moon only a few hundred kilometers across, tiny compared with major planets, almost easy to underestimate, and yet from its south polar fractures rise giant plumes of water vapor and ice particles, jets launching hidden interior material into the black. Those plumes are a gift to science, because instead of drilling through kilometers of ice, spacecraft can pass through what Enceladus throws upward, sampling the breadth of the ocean below. That is an extraordinary sentence. A moon breathing its buried sea into space. And what has been found in those plumes makes the story even more compelling. Water, yes, but also salts, organic molecules, and signs that the ocean may be interacting chemically with a rocky interior. This is where the hidden ocean story stops being only visual wonder and becomes something more serious. The materials in Enceladus's plumes suggest an active ocean, not stagnant water sealed forever in darkness, but a dynamic system, a living chemistry, if not yet living biology. Imagine this: a dark ocean under ice, the water below in contact with warm rock, chemical reactions unfolding over immense spans of time, tiny ingredients carried upward in icy plumes, a whole hidden environment leaving clues in frozen spray. There is something deeply moving in that, because the moon is not simply keeping its secret, it is leaking it, just enough for us to notice. And perhaps that is one of the most beautiful things in planetary science. Sometimes the universe does not answer directly. It answers in traces, in cracks, in plumes, in chemistry, in signals that become legible only when we learn how to read them. Now let us move to Titan. And here the hidden ocean story becomes stranger still, because Titan already has visible liquids on its surface, lakes and seas, but not of liquid water, of methane and ethane. Titan is one of the most dreamlike worlds in the solar system. An orange haze, a thick atmosphere, rivers, shorelines, rain, liquid weather. But all of that happens at temperatures so cold that water there behaves like rock. What flows on Titan's surface is not water, it is hydrocarbon liquid. And yet beneath Titan's crust, there may still be another ocean. A hidden internal sea of water mixed perhaps with ammonia. A buried ocean beneath a world that already looks like a strange alternate Earth from above. Imagine this: a moon with weather, clouds, rain, rivers, lakes, seas, but not the kind you know. Then under all of that, below the crust, perhaps another deeper sea still hidden from view. A world with liquids above and below, and neither of them ordinary. That makes Titan one of the richest examples of how alien ocean worlds can become. It reminds us that when we say hidden oceans, we are not talking about copies of Earth. We are talking about environments shaped by different temperatures, different chemistries, different pressures, and different histories. And that matters, because one of the easiest mistakes in astrobiology is to imagine that habitability must look familiar. But the universe may be under no obligation to repeat Earth's exact design. It may create conditions for chemistry and perhaps life in forms and settings that feel deeply strange to us. Imagine this: a buried ocean under ice on Europa, a venting internal sea on Enceladus, a layered liquid world on Titan, different moons, different architectures, and yet all of them forcing the same question: how many oceans can exist without ever touching open air? That is what makes this topic so powerful. It widens the map of what counts as a water world. It loosens the old assumption that habitable places must look temperate and bright from the outside. It suggests that some of the most promising environments in the solar system may look frozen, sealed, and lifeless at first glance. And that is a humbling lesson. The universe may hide its most interesting waters under surfaces we once dismissed. There is also something quietly emotional in that. We are surface creatures. We trust horizons. We trust sunlight. We trust open water under open sky. But hidden ocean worlds ask for a deeper imagination. They ask us to believe that darkness can still contain movement, that burial does not mean emptiness, that silence does not mean stillness. Imagine this: miles of ice above you, no wind, no blue sky, no visible waves, and still, far below, an ocean moving through the dark, perhaps with currents, perhaps with dissolved salts, perhaps with chemistry unfolding in ways we have barely begun to understand. That image changes the emotional meaning of the solar system. It makes it wetter, deeper, more concealed, more alive with possibility. In the next part, we move closer to the biggest question hidden ocean worlds raise. Could anything actually live there? Not in fantasy, not in giant creatures beneath the ice, but in the small, serious, scientific sense. Could darkness, water, energy, and time be enough? For now, rest with this. Europa, Enceladus, and Titan are not just cold moons in the outer solar system. They are some of the most compelling hidden water worlds we have ever found. Frozen above, active below, and far stranger than their quiet surfaces first suggest. Now we move toward the biggest question of all. Not whether these oceans exist, not whether they are deep, not whether they are strange, but whether anything could actually live there. Not in fantasy, not in giant creatures moving through the dark, not in stories of hidden civilizations under the ice, but in the small, serious scientific sense. Microbial life, simple life, persistent life, the kind of life that might survive where there is no sunlight at all. Because once hidden oceans become real places in the mind, the next question arrives almost immediately. Could darkness, water, chemistry, and time be enough? Imagine this: a buried sea under kilometers of ice, no sunrise, no seasons in the ordinary sense, no open sky, no photosynthesis in the way surface life on Earth usually depends on it. And yet below, perhaps, heat from rock, chemical gradients, minerals in motion, water kept liquid by gravity and internal energy. That is where the possibility becomes serious. Because life, at least as we understand it on Earth, does not require beauty. It does not require blue oceans under daylight. It does not require forests or weather or horizons. It requires conditions. And some of those conditions may exist in hidden oceans. The most important lesson Earth has given us here comes from its own deep sea. Far below sunlight, near hydrothermal vents, entire ecosystems survive using chemistry rather than light. Microbes feed on chemical gradients. Larger organisms build around them. Life persists in darkness not because darkness is friendly, but because energy and chemistry continue. That changed the imagination of astrobiology forever, because it broke one of the oldest habits in human thought. the habit of treating sunlight as the only real center of life. Imagine this: a black seafloor on Earth. No daylight, no photosynthetic plants, no visible warmth from the sky above. And yet around a vent, life gathers. White organisms, strange bodies, microbial systems, chemistry feeding persistence. If life can do that here, then the idea of life in a buried alien ocean becomes less like fantasy and more like a scientific possibility worth testing carefully. That does not mean Europa or Enceladus are alive. It means they are no longer easy to dismiss. Europa matters here because it may combine several of the most important ingredients in one place: liquid water, internal energy, a rocky seafloor below, and perhaps oxidants or other chemically useful materials moving down from the surface ice. This last part matters because life does not only need water, it needs disequilibrium, something to exploit, something to feed on chemically, a system that is not static. And Europa may not be static. Its surface is cracked and reshaped. Its ice may exchange materials with the ocean below. Its interior may remain active through tidal heating. All of that raises the seriousness of the question. Not proof, but seriousness. Imagine this. The ocean below Europa's ice is not just a buried pool of cold water. It is a system, a sealed, pressured, dark environment linked to rock below and ice above. The chemistry may be complex. The energy flows may be subtle. The timescales may be immense. Given enough time, enough interaction, enough internal motion, the moon may have had every opportunity to attempt something like life. That sentence should stay cautious. Attempt something like life. Because science owes the unknown respect. We do not know whether life ever began there. We do not know whether the chemistry is rich enough. We do not know whether the ocean has remained stable in the right way for long enough. But we do know this. Europa is one of the few places in the solar system where the question is genuinely strong. Now imagine Enceladus. In some ways, the case becomes even more emotionally powerful. Because Enceladus does not only hide its ocean, it samples it for us. Its plumes rise from the South Polar region and carry interior material into space. That means we can study clues from the ocean without drilling through the ice. This is one of the reasons Enceladus feels so extraordinary. A hidden sea revealing itself through spray. And what that spray contains matters deeply. Water, salts, organic compounds, hydrogen. Signs of water-rock interaction. Signs that the seafloor below may be chemically active. Hydrogen especially became a striking clue, because on Earth, hydrogen-rich environments can feed microbial life. Not proof of life elsewhere, but a reminder that the chemistry below Enceladus may not be passive. It may be energetic enough to matter biologically. Imagine this: a dark ocean under ice, its water touching warm rock, chemical reactions producing hydrogen, that hydrogen rising through water, trapped in plumes, carried upward and released into space. A moon leaving behind evidence not of biology, but of habitability. That distinction matters. Habitability is not life. It is the possibility of life, the permission structure, the environment in which life might exist if the chemistry and history align in the right way. And Enceladus, small and bright and easy to underestimate, may be one of the clearest habitability candidates beyond Earth. Now Titan enters differently. Titan is not the easiest place to imagine as a water-based hidden biosphere in the same way Europa and Enceladus are. Its chemistry is stranger. Its surface is colder in a different register. Its visible liquids are hydrocarbons, not water. And yet Titan may also hide a deep internal ocean. That makes Titan less of a simple ocean candidate and more of a layered mystery. A world where several forms of chemistry coexist at different depths. A moon with rivers and lakes above, and perhaps a buried water ocean below. Imagine this: a surface shaped by methane rain, clouds in a thick orange atmosphere, lakes cold enough to be made not of water, but of liquid hydrocarbons. Then, far below, another sea, hidden, water-based, buried under layers that make Titan unlike any world we know. Titan matters because it reminds us that the universe may create overlapping chemical worlds. Not one clean environment, but layers of possibility. And if life can arise in unusual conditions, Titan may teach us how broad our imagination still needs to become. That is one of the central lessons of hidden ocean worlds. The question is not only, is there life? The deeper question is, how wide is life's possible range? For a long time, habitability was imagined too narrowly. A planet with surface water near a star. Something temperate. Something Earth-like enough to be emotionally easy to picture. But ocean worlds beneath ice have widened that map. They suggest that habitable environments may exist in darkness, under pressure, and far beyond what older intuition once allowed. Imagine this: an ocean with no sunrise, a sea with no waves visible from above, a world no one would have called gentle or inviting. And yet, under the ice, enough water and chemistry and energy for the possibility of persistence. That image changes the solar system. It makes it feel less like a collection of dead, frozen bodies, and more like a place with hidden internal rooms. Rooms of water, rooms of chemistry, rooms where life might at least be thinkable. Of course, caution must remain. The universe is under no obligation to fill every habitable place with life. Water is not life. Chemistry is not life. Energy is not life. And possibility is not evidence. That is why the most honest scientific stance is one of disciplined hope. Strong interest, careful measurement, no fantasy inflation, no false certainty. Imagine this: a spacecraft passes through the plumes of Enceladus, or orbits Europa, studying its surface, its gravity, its hidden sea, or one day perhaps descends with instruments capable of reading chemistry more deeply. The great question remains the same. Not, do we want life to be there? But, what does the evidence actually say? That is the right kind of wonder. A wonder that stays close to evidence. A wonder patient enough to let the universe answer in its own language. And perhaps that is why hidden ocean worlds feel so moving. They are not easy hopes. They are careful hopes. The kind born from chemistry, gravity, geology, and long observation. The kind that make the solar system feel at once colder and more alive with possibility. Imagine this: beneath frozen crusts, whole seas move in darkness. No sunlight touches them. No eye has seen them directly. And yet they may be among the most serious places we know to ask whether life can begin more than once. That is an astonishing sentence. Not because it proves anything, but because it turns remote moons into meaningful worlds. Not decorations, not icy leftovers, but candidates. In the next part, we step back and gather what these hidden oceans have changed in our understanding of the solar system, why they matter beyond the search for life, why they widen the map of habitability itself, and why some of the most important places in the search for life may lie not under stars, but under ice. For now, rest with this. Europa, Enceladus, and Titan are not just cold moons. They are worlds that force us to ask whether water, chemistry, energy, and time might be enough, even in darkness, even under ice, even far from the warmth we once thought life needed. Now we step back. Because hidden ocean worlds do not matter only because they might contain life. They matter because they change the shape of the solar system in the mind. For a long time, the outer solar system felt simple. cold, frozen, remote, a place of beautiful surfaces and dead interiors. The warm worlds seemed active, the icy worlds seemed finished. But hidden oceans changed that story. They suggested that some of the quietest-looking moons may still contain movement, heat, chemistry, depth, perhaps even habitable environments. That is a profound correction, because it means appearance is not enough. A frozen surface may hide a working interior. A silent moon may still be geologically alive. A world that looks closed may still be dynamic underneath. Imagine this. You look at Europa, Enceladus, or Titan from far away. From a distance, each one seems sealed. A white shell, a pale orb, a hazy moon in cold orbit around a distant giant planet. Nothing in that first image naturally tells you that oceans may lie below. Nothing in that first glance says movement. Nothing says life might even be worth asking about. And yet that is exactly the lesson hidden ocean worlds force us to learn. The most important environments are not always visible ones. This matters beyond astrobiology, because once you accept that buried oceans can exist beneath frozen crusts, you begin to see the solar system differently, not as a collection of surfaces, but as a set of layered worlds. Worlds with interiors, worlds with hidden energy, worlds that cannot be understood by appearance alone. Imagine this: a moon with a bright, icy shell. Below it, a dark ocean. Below that, rock. Below that, internal heat slowly moving outward. A whole vertical world hidden from simple sight. Not a flat object, a layered system. This is one of the deepest changes hidden oceans brought into planetary science. They turned moons from scenery into environments. Europa stopped being only a bright, icy world near Jupiter. Enceladus stopped being only a small, frozen moon of Saturn. Titan stopped being only the orange world with strange lakes and haze. Each became a candidate for internal complexity. That phrase matters. Internal complexity. Because complexity inside a world means history, motion, exchange, possibility. And hidden oceans give us exactly that. They suggest that some moons have not simply been sitting in cold silence for billions of years. They may have been working internally the whole time, flexing, heating, circulating, changing. Imagine this. An ocean under ice does not need to be dramatic to matter. It only needs to persist. A slow current, a stable chemistry, a long time scale, a rock-water boundary where energy continues to move. That alone is enough to turn a frozen moon into a serious world. This is why hidden oceans widen the map of habitability so much. They tell us that habitable conditions may not require Earth-like surfaces. They may not require blue skies or open seas, or sunlight falling on liquid water. They may exist in buried places, in pressurized darkness, far from what older imagination once called welcoming. That is one of the most beautiful scientific shifts of the last few decades. The universe did not become stranger by breaking its laws. It became stranger by obeying them more deeply than we first expected. Gravity creates tidal heating. Ice insulates. Water remains liquid below. Chemistry continues. A hidden ocean forms. The logic is severe, but it opens worlds. Imagine this. The habitable zone around a star once seemed like the most obvious map for possible life. A band of distance where liquid water might exist on a planet's surface. That still matters. But hidden oceans remind us that the habitability story is larger than sunlight alone. There may be habitable niches under ice, powered not by starlight, but by internal energy. That changes the emotional architecture of space. It means the search for life is no longer only a search for little Earths. It is also a search for buried systems, for dark seas, for internal worlds. And in some ways, those may be even more common, because icy moons are not rare accidents. They are part of how the outer solar system is built. And if our own solar system can produce several ocean worlds beneath ice, then it becomes natural to wonder how many more might exist elsewhere. Imagine this. Every giant planet system may host moons, some large, some icy, some flexed by tidal forces, some with the right structure to hide liquid water below. The implication begins to widen quickly. Perhaps hidden oceans are not unusual at all. Perhaps they are one of the universe's quieter habits. That possibility should linger. Because if ocean worlds under ice are common, then the number of places where chemistry and perhaps life could unfold becomes much larger than older models once suggested. This is where hidden oceans stop being a niche topic. They become cosmically important, not because we know they are alive, but because they multiply the number of serious environments. They make the universe feel less barren, not by optimism alone, but by structure. Imagine this, a galaxy full of stars. Around many of those stars, giant planets. Around some of those planets, moons. And among those moons, perhaps many frozen shells hiding buried seas. The universe suddenly feels less like a desert of rocks and more like a place with sealed reservoirs, secret water systems, dark habitats waiting beneath ice. That does not prove life is common, but it changes what possible means. And there is another reason hidden oceans matter. They teach us caution about surface judgment. This is a lesson science returns to again and again. The visible layer is not always the decisive one. The surface is not always the truth of the system. Sometimes the deeper structure is doing the real work. That is true in galaxies, true in black holes, true in dark matter, and now, here again, true in icy moons. The universe loves hidden interiors. Imagine this, a moon that looks dead from the outside, but below, circulation, heat, salt, pressure, chemical exchange, perhaps a whole ocean shifting in darkness for millions or billions of years. That is a humbling image. It reminds us how easily we confuse stillness with emptiness. And maybe that is one of the reasons hidden ocean worlds feel so emotionally strong. They carry a quiet reversal. What looked frozen may be active. What looked sealed may be dynamic. What looked dead may be worth asking about again. Science grows through those reversals, not by abandoning evidence, but by learning that evidence can point beneath the obvious. This is why future missions matter so much. Europa Clipper, possible Enceladus missions, future Titan investigations. Each one is not merely a voyage to a moon, it is a descent, conceptually, beneath the surface, a way of asking what lies under the first visible answer. Imagine this, a spacecraft orbiting Europa, mapping the ice shell, reading the gravity field, scanning for signs of internal water and exchange. Or one day, flying again through the plumes of Enceladus, tasting a buried ocean in frozen spray. These are not just technical missions. They are acts of deeper looking. And hidden oceans deserve that attention, because they may represent one of the most important categories of worlds we know. Not because they are easy, not because they are inviting, but because they force us to widen the definition of where meaningful environments can exist. That widening may be the biggest gift they offer. The universe is not only stranger than we thought, it is more layered, more sealed, more interior, more rich with hidden systems that only patience and evidence can reveal. Imagine this, miles of ice above, dark water below, a whole sea hidden from direct sight, a world whose true importance lies under the surface. That image no longer feels like fantasy. It feels like part of the solar system's real design. And perhaps that is the quiet revolution hidden oceans bring. They make buried water feel normal enough to study seriously, and extraordinary enough to keep changing the way we picture the cosmos. In the next part, we gather everything together: the buried seas, the dark chemistry, the widened map of habitability, and the final question that remains in the mind after all of it. If the universe is hiding whole oceans beneath ice, what else might it still be hiding in places we have barely learned to see? For now, rest with this. Europa, Enceladus, and Titan matter not only because they may contain hidden water, they matter because they teach us that some of the most important worlds are not the easiest ones to read from the outside. Frozen above, active below, quiet in appearance, and far deeper in meaning than they first seem. Ixinati. Now we arrive at the final view. Not only that hidden oceans may exist, not only that they may be deep, dark, and active, not only that they may widen the search for life, but what it means that the solar system may be hiding whole seas beneath ice. Because this changes more than one scientific question. It changes the emotional shape of space. For a long time, the imagination of the cosmos was built around surfaces, planets under stars, worlds with visible skies, landscapes you could picture from above. A place seemed important if you could imagine standing on it, seeing it, naming its horizon. Hidden ocean worlds quietly undo that habit. They suggest that some of the most meaningful places in the solar system may not be visible in any ordinary way. They may lie below, beneath crusts, under pressure, behind frozen surfaces that reveal almost nothing at first glance. That is a profound shift, because it means reality may be richest where it is least obvious. Imagine this, a moon that looks simple from far away, pale, cold, closed, a world you might once have passed over in the mind, and yet beneath that stillness, an ocean, not symbolic, not imagined, a real body of water, dark, silent, moving below the ice. That image changes the meaning of the word world. A world is no longer only what appears on the surface, it is also what is happening underneath. The layers, the hidden exchanges, the unseen structure, the interior life of a place. This is one of the deepest gifts hidden oceans give to science. They teach us to think in layers, not surface first and surface only, but surface and depth, appearance and interior, frozen shell and active sea. And perhaps that is why these worlds stay in the mind so strongly. They are not just scientifically interesting, they are emotionally corrective. They remind us how often the universe hides its most important things below the first visible answer. Imagine this, Europa turning under Jupiter's gravity, Enceladus releasing icy plumes into space, Titan wrapped in orange haze above a world of liquids, both visible and buried. Different moons, different chemistries, different structures, and yet all of them quietly saying the same thing: do not trust the surface too quickly. That lesson goes far beyond these moons. It touches the larger search for life. Because if hidden oceans are real and perhaps common, then the number of meaningful environments in the universe expands. Not because every buried sea is alive, but because the map of possibility becomes wider, deeper, less dependent on surface warmth and visible water under open sky. That matters, because it shifts the search for life from one narrow image to a broader and more mature one. Not only little Earths, not only blue planets, but sealed worlds, dark worlds, interior worlds. Imagine this. Across the galaxy, countless stars. Around some of them, giant planets. Around some of those planets, icy moons. And within some of those moons, buried oceans held liquid by pressure, chemistry, and internal heat. The universe begins to feel less empty, not proven alive, but less simple, less barren, more prepared for hidden complexity. That may be one of the most beautiful things hidden ocean worlds have done. They have not given us easy hope. They have given us serious hope, careful hope, evidence-shaped hope. And that distinction matters, because science does not ask us to dream carelessly. It asks us to remain faithful to what the evidence allows. And what the evidence allows here is already astonishing. Liquid water may exist far from sunlight. Energy may persist inside frozen moons. Chemistry may continue in dark seas no eye has ever seen. Possibility may survive where older imagination once saw only ice. Imagine this: miles of frozen crust above, dark water below, no sunrise, no wind, no visible waves, and still, a whole hidden environment continuing in silence. That is no longer a fantasy image. It is one of the most serious realities modern planetary science has placed before us. And there is something quietly moving in that. Because hidden oceans make the solar system feel more intimate. Not because they are easy to reach, not because they are familiar, but because they are worlds with interiors, worlds with concealed depth, worlds that feel less like objects and more like places. Places with history, places with chemistry, places where time has been doing hidden work for ages. That changes the tone of the outer solar system. It is no longer only a graveyard of frozen remnants. It becomes a region of sealed motion, buried seas, unseen exchanges, internal life in the geological sense, and perhaps one day in the biological sense too. Imagine this: a spacecraft far in the future reading the chemistry of a plume, mapping an ice shell, tracing the thickness of a buried sea, or listening for the motion of water under crust. Every one of those acts would be more than exploration. They would be a way of reading beneath appearance, of asking what the surface failed to say. That may be the great philosophical lesson of hidden oceans. The first visible answer is not always the true depth of a thing. And the universe seems to love that lesson, again and again, in dark matter, in black holes, in buried seas, in structures that reveal themselves through consequence rather than easy display. Reality is often deeper than its surface, and science, at its best, is how we learn to trust that depth without inventing what is not there. Imagine this: the night sky above you, beautiful, distant, familiar in its own ancient way. And somewhere within that larger darkness, moons drifting around giant planets, carrying seas beneath ice, entire oceans hidden from ordinary sight, worlds where water may move in silence for millions or billions of years. The sky has not become less beautiful, it has become deeper. That may be the final feeling these worlds leave behind. Depth. Not only physical depth, conceptual depth, emotional depth. The sense that the universe contains more interior life than the eye first grants it. So if you carry anything with you from tonight's journey, let it be this: some of the most fascinating oceans in the solar system may not lie beneath open sky. They may lie in darkness, under ice, far from the warmth we once thought life needed. Europa, Enceladus, Titan, frozen above, active below, and quietly changing how we understand what a world can be. Now the journey begins to quiet. The ice grows still in the mind. The dark seas drift back into thought. The question remains open, but no longer vague, only deeper. For now, let the stars remain where they are. Let Jupiter and Saturn drift quietly through their old orbits. And let the idea settle gently into the dark. The universe may be hiding whole oceans in places we once assumed were empty. Rest there for a moment, and when sleep comes, let it come softly.